In this video, we'll look at solving another type of equation that is an absolute value equation. So an absolute value equation is an equation that involves an absolute value expression. And these are often used to solve real-world problems that deal with distance and error. Let's first review what absolute value means. Do you recall that if you see vertical bars around the number -5, which we read as absolute value of -5, this means to determine the distance -5 is from 0 on the number line, and -5 is 5 units from 0 on the number line. If I wanted to find the absolute value of 37, that means to determine how many units is 37 from 0 on the number line, and that would be 37 units. So the absolute value of -230 is how many units is -230 from 0? Well, that is 230 units. So note that absolute value is always positive. It can be 0 if we think about taking the absolute value of 0. How far is 0 from itself? Well, it's 0 units from itself. So absolute value can be 0 or positive, but the absolute value of a number will not be negative. So when we solve absolute value equations, we need to be mindful of that meaning. Here's an example, very simple example, absolute value of x equals 4. That's basically telling me find all the numbers whose absolute value is 4. So when we think about a number line, this means tell me all the numbers whose distance from 0 is 4. Well, we can move to the right from 0, 4 units to get to 4. But we can also move to the left 4 units to get to -4, right? But in each case, 4 and -4 are 4 units from 0. So therefore, this equation has two solutions. It's true that x can be either -4 or x can equal 4. So the solution set of that equation is -4, 4, or we can write that in a compact form as plus or minus 4. Okay, so if an absolute value of one number is 4, there are two numbers that satisfy that, -4 and +4. What about solving absolute value of x is equal to 0? This means find all the numbers whose distance from 0 is 0. Well, there's only one number, and that is 0. So in this case, x is equal to 0. The solution set would just be 0. And the third example is absolute value of x is equal to -7. This would tell me to find all the numbers whose distance from 0 is -7. But I can't move a -7 units, and so there is no number whose absolute value is -7. So there would be no solution for this equation, which we write as the empty set. So there are actually 3 cases of solving an absolute value equation. That is when the right-hand side is a number that's positive, 0, or negative. So let's look at this property. There are 3 parts to it to solve an absolute value equation. If the absolute value of x is equal to k, and k is positive, right? K is greater than 0 means it's positive, then the solutions are found by setting x equal to k or x equal to -k. So there are 2 solutions in that case. If the absolute value of x is equal to 0, then the only value that makes that true is when x is equal to 0. So there will be one solution in this case. And then thirdly, if absolute value of x is equal to k, and k is less than 0, which means that k is negative, then there are no solutions because there are no numbers that have a negative distance. So we have 3 cases where we'll either have 0, 1, or 2 solutions. Now the other big part about this property, which is implied, is that the absolute value bars must be isolated to one side. And in the text, I talk about this as relating this to like a field goal, right? The field goal, the goal post on a football field. To kick the field goal, you got to get down the field and clear everything else off, right? And that's kind of what we're doing here. We want to get everything cleared away from the absolute value so that we can kick the goal and make some points. So we're going to isolate the absolute value, and then we will apply one of these three cases. Now also, x doesn't just have to be a single variable. X represents an algebraic expression in these cases. So let's look at some examples. First one, absolute value of x is equal to 5. We have the absolute value bars isolated equal to a positive number. So that means then that x has to equal to -5 or 5. Right, what numbers have an absolute value of 5 or a distance from 5 from 0? That's -5 and 5. The solution set is -5, 5. What about the absolute value of x plus 3 equals 7? So the absolute value bars are isolated. We're thinking about what does the number inside have to be so that its absolute value is 7? Well, that number inside can either be positive 7 or it can be -7. Right, we have to set the expression inside equal to plus or minus 7. We can solve those equations by subtracting 3 to get 4 or -10. So the solution set is -10, 4. Now also we can plug in to check, right? If I substitute -10 in place of x, -10 plus 3 in the absolute value, is that equal to 7? Yes, because that gives me absolute value of -7. Is that 7? Yes, it is. So remember that we're trying to find what values of x make that equation true. Part C is absolute value of 2x plus 4 minus 8 equals 2. So the first thing we have to do is to isolate the absolute value bars, and we can do that by adding 8 to each side. So we get the absolute value of 2x plus 4 equals 10. Now we think about what does this number inside have to be for its absolute value to be 10? And that has to be 10 or -10. So we set 2x plus 4 equal to 10, or 2x plus 4 is equal to -10. Subtract 4 from each side. So we get 2x is equal to 6, and then divide by 2 to get x equals 3. Or 2x equals -14, divide by 2 to get -7. The solution set then is -7, 3. Part D is absolute value of x plus 2, then plus 9 equals 4. So again, we got to isolate the absolute value bars by subtracting 9 from each side. So the absolute value of x plus 2 is equal to -5. But then this says what numbers have an absolute value of -5, which means what numbers have a distance from 0 that's -5, but that doesn't make sense, right? That's a contradiction. I cannot have an absolute value equal to a negative number, so there are no solutions of this equation. And I know it's tempting, right? You want to be able to solve it, but I can't. Absolute value equal to a negative number, cannot solve. One other property about absolute value equations is when we have absolute value on each side of the equation. So this says if absolute value of x is equal to the absolute value of y, again, x and y represent some algebraic expression, then this is only true if the two expressions inside are equal to each other or if they're opposite. So that means that either x has to equal y or x equals -y. Let's look at a specific example. Like absolute value of 3 is equal to the absolute value of 3, right? Because both of those values is 3. But it's also true that the absolute value of 3 is equal to the absolute value of -3. because both of those values is 3. So either the numbers inside the absolute value bars have to be the same, or they have to be opposite for that to be a true statement. So when we want to solve an equation like this, the absolute value of 5x plus 2 equals the absolute value of 3x minus 4, then the only way that's true is if the inner expressions are the same, that is, if 5x plus 2 is equal to 3x minus 4, or if 5x plus 2 is equal to the opposite of 3x minus 4. So 5x plus 2 equals 3x minus 4, we can subtract 3x from each side to get 2x plus 2 equals negative 4. Subtract 2 to get 2x equals negative 6. And then divide by 2 to get negative 3. Or the second equation, we have to first distribute the negative 1 on the right side to get 5x plus 2 equals negative 3x plus 4. And so we would have to add 3x to get 8x plus 2 equals 4, and then subtract 2. So 8x is equal to 2, and then divide by 8, which is 2 divided by 8, or simplified as 1/4. So my solution set would be negative 3, 1/4. And then I want to show you just one application problem, very similar to what is worked in the text, but this is a hazardous chemical spill occurred in a mile marker 425 on an interstate. Emergency management personnel stated that motorists should be a minimum of 10 miles from the site of the spill. At what mile markers should police block traffic to keep motorists safe at a minimum distance from the chemical spill? So what we're saying here is that we're at mile marker 425, and we have to go 10 miles in each direction to block traffic. And I know you could figure that out in your head, right? Adding and subtracting 10 from the 425, but algebraically this is saying if x is the mile marker, it must be true that the distance between the mile marker and 425 is 10 miles. So we represent the distance between two numbers with the absolute value. So the absolute value of x minus 425 is equal to 10. So this means that x minus 425 has to be either 10 or x minus 425 has to be negative 10. I can add 425 to each side to get x is equal to 435, or if I add 425 to negative 10, I get 415. So the mile markers should be 415 and 435 is where we have to block traffic.